next two sessions will be Mr. Arpan Basu. He is a final year computer science student of IIT Bombay. He got All India rank 59 in JEE Advanced 2020 and then chose to go to IIT Bombay Computer Science Engineering. He cleared RNO thrice and also Kishore Vaidyanik Protsahan Yojana awardee with All India rank 58. He got All India rank 6 in NMTC exam conducted by AMTI Chennai. Please join me in welcoming Mr. Basu.
Hello, am I audible to the backbenchers? Yeah. So I'm Arpan and pleased to be back here. So I was from a same family of schools, from school 4, not school 2. But I was also a student here. I passed out in 2020. It always feels good to come back. And I was told that all of you have gotten above a certain threshold of marks in IOQS. So I presume that you are interested in that Olympiads and uh, would want to learn more. So the way I planned this session is that I will give you some problems and then ask you for your opinions on them. What do you think, how much progress you can make, and then probably give you the solution. So, so that way, if you think about the problems a bit on your own, not much, but even say 5 to 6 minutes, the solution will sink in better. So it would be really nice if all of you interacted and told me what you think. And by the way, you all are familiar with proofs and stuff, right? So like you have a statement, what it means to prove something, what it means to say a proof by contradiction or proof by induction. Do you guys know all of these things? Nevertheless, I will not assume much and I will cover whatever is necessary. Just ask. So the topic of this session would be polynomials. Uh, So, as I said that I will not cover much theory, but I will tell you maybe one small result, one small problem solving technique, and then give you some illustrative problems on it. So, the first thing we will be covering is integer divisibility. So, let P be a polynomial with integer coefficients. Right. Uh, and let AB be also integers. Then A minus B divides B minus B. Do all of you know this? It's not very hard to see. So you all know what a polynomial is, right? when I say that say P is a polynomial, I mean that Px equal to an x to the power n plus an minus 1 x to the power n minus 1 a1 x plus a0. And the degree of this polynomial is n, provided an is not 0. Right. So we call this a polynomial. So here I am taking a polynomial with integer coefficient. So an minus 1, a1 is 0, all of them are integers. In general, you can deal with real polynomials with real coefficients and all sort of polynomials. So what I am saying is that if I give you two integers a and b, then pa is an a to the power n plus a minus 1 a to the power n minus 1 plus a1 a plus, and pb is in b to the power n minus 1 b to the power n minus 1 plus a. So what I am claiming is that the difference of these two things is divisible by a minus b. Now that I have written it out explicitly, can you now see why this must work? It's clear, right? So PA minus PB basically will become AN a to the power n minus b to the power n plus AN minus 1 a to the power n minus 1 minus b to the power n minus 1 up to A1 a minus b, and the A0 term will cancel out. Right. Then A minus b divides all of these things, so A minus b divides this. Right. So this is clear, right? So now we'll see some problems based on this. Have all of you written this one? Let P. So by the way, instead of continuously writing let P be a polynomial with integer coefficients, I'll simply write Zx. So Zx is the set of all polynomials with integer coefficients. So when I write P in Zx, I mean that P is a polynomial with integer coefficients. Okay. So let P be a polynomial with integer coefficients, and let A, B, C be integers such that PA equal to B, PB equal to C, PC equal to A. Prove that A equal to B. Is a statement clear to all of you? So, any thoughts on how you might begin? Given that we are dealing with integer divisibility, I think it should be clear what we have to use. Otherwise, I would have stated that result.
That will be a minus b of divided by b of a minus b.
Sure. So, A minus B divides B of A minus B. Which is
A minus b divides b minus c.
okay. Can you say something more?
We can also do like b minus c divided something like b minus c divided.
So, if any of you are feeling lost, please tell me. So, is this statement clear to all of you? We can also write B minus C divides C minus A. Right? And okay. So, what does this tell you? So, basically, you have three numbers A minus B, B minus C, and C minus A, and they divide each other. And we have to basically prove that all of these differences are actually zero. So, how do you go about it?
And we can do that a minus b is
really, because some of these differences will be negative also, right? So you can have 2 divides minus 2. Did you get that point?
We can say that A minus B divides B minus C and B minus C divides C minus D. That means A minus B will divide C minus D. And we already know that C minus A divides A minus B. Both can occur together only if they are equal.
Plus minus, they may be negatives of each other. Did you get that point? Actually, when nothing strikes you, simply write down what this means. Yeah.
We can say that A minus B x equals C minus C also is like that.
Exactly. So did all of you get what she said? So A minus B divides B minus C, right? So we can write B minus C is x into A minus B, where x is some integer, right? So now you don't have issues of whether this is positive, negative. I mean, x is an integer; it can be anything, right? And similarly, we can write C minus A is y into B minus C for some integer y, and A minus B is z into C minus A for some integer z. Now what do you think? So we can get.
Multiply all.
So what do? We multiply both sides, all sides basically. So you multiply the LHSs, multiply the RHSs. What do you get? B minus C, C minus A minus B equal to x, y, z, A minus B, B minus C, C minus A. Right.
X y z is equal to 1 minus x y z equals to x y z equal to 1 and equal to 1 and
Slight catch here. So the slight catch means that if this thing is 0, then you can't cancel it. So you can also we can subtract it. So basically, all you can say that if one of them is 0, then you can deal with that case separately. So suppose assume that A equals B, then you get PA equal to A and PA equal to C. So if suppose if A equal to B, right, then you get that PA equals A and B equals C, then A must be equal to C. So if A equals to B, then all of them are equal. So without loss of generality, we can assume that none of them are equal. Right? So if none of them are equal, then you can cancel this. Always remember when you are cancelling something on both sides of the equation, you have to ensure that it is not 0. Otherwise, you have those proofs where you prove 1 equals 2. Stuff like that. So you get that x, y, z is 1. Are we done now? Why not? You can have 1 minus 1 minus 1. What will you do now?
Like x can be either 1 or minus 1. So we can put the value of x in the first equation.
Yeah, so now basically you start doing case law, right? So when x, y, z is 1, what all cases are possible? If all of them are 1 and 2 of them are minus 1 and your permutation is right. So if all of them are 1, what happens? You get b minus c equals a minus b, c minus a equals b minus c, A minus B equals C minus A. So basically all of these things are equal. Right? Very good. If all of these things are equal, then suppose this is B, right? Then B is A minus B. C is B minus B. C minus A is minus 2B, right?
C minus A is B. Because
So yeah, C minus A is B from here, but from here what do you get? Minus 2B, right? So minus 2B equals B. You get B equals 0, which is what you wanted. So this is one case. Can you deal with the other case similarly? How sure that it does not happen? Can I leave that to you?
we have to check if it's
Yeah, we have to check. Okay. Suppose 1 minus 1 minus 1, right?